Hello! Now, today we are going to be looking at where algebra becomes very powerful, where we can start to take stories from the world and turn them into maths. So we've seen this a little bit in that they've given you English style questions in the past, and now we're going to look at how we can really start to push that out and start to get real world use out of our algebra. So if we take a very straightforward example, where we have to do very little translating, a number divided by 13 is 4. Find the number. Well, let's take what we know. A number. We don't know what that number is, so what could we call it? Well, we often call it x. We don't have to. You could call it m or a or whatever you prefer. But x is very commonly used, so it's helpful to get used to using it. So we have a number, and what do we do to it? We divide it by 13. Well, before we worry about anything else, let's just divide that number by 13. So that's part of our English, and we're told that when we divide that number by 13, our answer is 4. Well, that means that x divided by 13 is the same as, or is equal to, 4. So now we've said we have a number we don't know, let's call it x. We're told we divided it by 13, so we do that. And then we're told that the result of that is going to be 4. So it's equal to 4. And now we've gotten to that stage, we all know how we can rearrange this to find our number. We have x divided by 13. We want to end up with x by itself is equal to a number. So what do we need to do? We need to get rid of this divided by 13. So I know if I have 13 divided by 13, I'll end up with 1, which is what I want on my left-hand side. And if I do that to the left-hand side to keep my balance, I must do it to the right-hand side. So I have 4 multiplied by 13, which works out to 52. So that is my basics of it. If I'm told I have a number I don't know, I'm going to call it x or a or whatever letter I like, and then I'm going to see what I need to do with that information moving forward. Now, let's have a read of our next question. 3 consecutive numbers add to 21. What is the smallest number? So this is our big issue here, consecutive. Now some of you will know what it means, but a lot of you won't have come across that word before. Consecutive means one after the other. So if I start at the number 10, the next consecutive number is 11. And the next consecutive number after that is 12. Well, what are we actually doing in practice? We're adding 1 each time. So we have 10, and then we have 10 plus 1, and then we have 10 plus 2. So that's what our consecutive numbers mean. If we had 23, the next consecutive number would be 24. So we'd have 23, and then the next number would be 23 plus 1. And the next consecutive number, we'd have 25, would be 23 plus 2. So that's what consecutive numbers mean. So let's put that into practice. I have 3 consecutive numbers, so I know I have to start at a number. So if I start at a number, I don't know what number it is yet, so I'm going to call it x. Or actually, just for not using x all of the time, because we don't have to, I'm going to call it a. So I start out with the number a. I don't know what it is yet. And I know the next consecutive number, well, if I follow my pattern, is going to be a plus 1. And the next consecutive number after that is going to be a plus 2. So that's my 3 numbers. And I know if I add all these numbers together, I get the number 21. So a plus 1 plus a plus 2, my 3 numbers added together are equal to, are the same as 21. So now I have an equation that describes the English here. So let's put that into practice. We can add up like terms. We can see several like terms that we've got here. We have and A, and we have a plus 1 and a plus 2. So let's tidy up our equation. So we have a plus a plus a is 3a's. We have 3a's in total. And 1 plus 2 is 3 is equal to 21. Now I want to get a is equal to number. That's my aim. So I want to end up with at the end a is equal to a number. So let's do that. We're going to subtract 3 from both sides because I don't want this 3 on the left hand side. I only want a. So I have 3a is equal to 21 minus 3 is 18. Now I want to have 1a by itself. So I'm going to divide both sides by 3. I have 1a, 3 divided by 3 is 1, 18 divided by 3 is 6. So my smallest number, my a, my first number in my list is 6. Now it would be very easy for me to figure out what the other two numbers are as well. Well, if a is my first number, my next number, let's ignore that for a minute. Let's make my list. This isn't what I'm asked in the question, but I can work it out anyway. So I have 6 is my smallest number. That's what I was asked for, so that's my final answer. But if I was asked for all 3 numbers, as I often will be, I could go, my next consecutive number after 6 would be 7, and my next consecutive number after that would be 8. So that's how we could do a problem like that. Let's have a look at another example. When we double a number, so we have a number, let's call that m. When we double a number, 2m, so we multiply a number by 2, that would be doubling our number, and take away 5, the result is 1. So take away 5 is the next thing. So all I'm doing is translating exactly what it's written in English into maths. So I recognized I was told about a number, so I wrote down a number. And I wrote it down as a letter because I don't know what it is. And then I doubled that number, so I multiplied it by 2. Doubling something and multiplying it by 2, we know mean the same thing. So I did my first bit of my sentence, and then I did and take away 5, so I took away 5, and the result is 1. What does that mean? It means if I do this, I'm going to get 1. So it's equal to 1. Now I want to find out what my number is. So find out what m is. So my final aim is to have m equals a number. That's my aim. So let's rearrange my equation to achieve that. So I'm going to have, this is now back to what we're already familiar with, but I want to get minus 5 to 0 because I want to end up with m by itself on the left hand side of my equal sign. So I want to add 5 to the left hand side in order to get 0 numbers on my left hand side, and to keep the balance I must do the same thing on the right hand side. So I end up with 2m is equal to 1 plus 5 is 6, and then I know that twice m is going to be 6. So if I divide my left hand side by 2, I have 2 divided by 2 will leave me with 1m, which is what I want on the left hand side, but to keep the balance I must do the same thing on the right. So I have m is equal to 3. So 1m is equal to 3. That's what I was after. So we can see how we translate directly. Step by step, the sentence becomes a sentence in maths. Now let's try one that's a little bit more of a story. A child has a brother who is 9 years older than him. The sum of their ages is 19. How old is the child? Okay, so we're asked about a child's age. So let's call it C. So I have a child's age C. That's my first piece of information. And he has a brother who is 9 years older than him. So we have a brother. Brother is the child's age plus 9. So this is the child. The age of the child is C, and the brother's age must be, if he's 9 years older, it's the child's age plus 9. Okay, we've got that so far. And again, all I've done is write down exactly what the question tells me in mathematical language. So that's my first sentence dealt with. The sum of their ages is 19. Well, I know what a sum is. It means I add stuff together. So if I add their ages together, I get 19. So the child's age plus the brother's age. So this is the child's age. This is the brother's age. Is 19. So if I add their ages together, I get 19. How old is the child? So now I'm looking for the number C. I'm looking for the child's age. So now we're into stuff that we already know. Let's have a look for like terms. So we're always going to look for like terms before we do anything else. So I have a C here and a C here. So I'm able to add them together and I get 2C plus 9 is equal to 19. Now I want to get C by itself. I want to end up with C equals a number. 1C is equal to a number. So I don't want this plus 9 on the left hand side. So I'm going to get that to go to 0, and the way I get that to go to 0 is I subtract 9 away. Plus 9 minus 9 is 0, and I have to do the same thing to the right hand side to keep my balance. So 2C is equal to 19 minus 9 is 10. So 2C is equal to 10. I want to know what 1C is, so I want to divide both sides by 2. So I get 2 divided by 2 is 1C is equal to 10 divided by 2 is 5. So the child is 5, and it would make sense in this case to use units, wouldn't it? Because we're actually talking about someone's age. So that means 5 years old. So the child is 5 years old. And anytime you can see in a question that there are sensible units that you could be using, write them down. Maths is just a language, and we want to make sure that our language is as clear as possible. So if we're finding the age of a child, we're talking about how old they are in years. So in each of these cases, you can see how we started out with English and we translated it directly into maths. So if we're careful and we take the English sentence and we turn each part of it into maths, we'll be able to do anything that we need to in algebra. And that's what we need to be able to do for now.